Okay, should I get started?
Yes, please.
Thank you so much for the introduction and for having me. And today I'm going to give a talk called Data at Your Fingertips, Unlocking the Potential of People-Powered Research. So I'm really going to talk tonight about the Zooniverse platform and some of our really awesome discoveries that we've made on the Zooniverse platform and how you all can get involved in citizen science if you so choose. So I wanted to give a brief overview about what citizen science and the Zooniverse are. And one of the reasons that citizen science has really exploded is that with the expansion of big data, many research teams across a whole host of disciplines, not just astronomy, are left with more data than they really know what to do with. So they have observations or images, sound data, they have pictures or text-based data, and they don't have enough research or time to examine all of it individually. So oftentimes we turn to machines and machine learning algorithms, and these are all great, but machines require training and they're obviously not good at tasks that they're not programmed to perform. And I'll discuss a little bit later in the talk why the human eye working in tandem with machines is really the optimal solution for the future of citizen science. So over at Zooniverse, oftentimes we refer to citizen science as people-powered research. So like I said, scientists across many disciplines can post collections of hundreds of thousands of images, and anyone, regardless of their background, age, or location, I guess age matters a little bit because they have to have an email address and be able to type and read, but they answer a series of short questions and they help the research teams with an aspect of their data analysis process. And this is amazingly effective because there are many people looking at each subject. And so researchers ultimately synthesize their data much faster than if they were working alone. So the Zooniverse works in a specific way in that volunteers on the Zooniverse platform classify each subject, whether it be an image or a text file or a sound file, they do that independently. So it's not done in groups. And then depending on the project, between 3 and 80 people look at each data file. So then ultimately the responses are aggregated for consensus. And then the consensus data are made available to the research teams that partner with Zooniverse to put their projects on the platform. And then after 2 years, we require all of our research teams to make their data available to the public. And then volunteers can actually interact directly with the scientists behind the projects on what we call talk boards, which I'll describe a little later. So Zooniverse began with a single project called Galaxy Zoo, which launched in 2007. And the goal of this project was to process over 1 million images of galaxies from something called the Sloan Digital Sky Survey. And the goal at first was to just bin these 1 million galaxies into 2 different morphological categories, so spiral or elliptical. And originally, the PI of this effort assigned this task to one graduate student. And he did a back of the envelope calculation and determined that it would have taken him at least 3 years working 24 hours a day, 7 days a week to get all of this data analyzed. And having been a grad student recently, I can attest to the fact that we work many, many hours a week, but even that seemed a little bit excessive. So he created an online interface to crowdsource this data to the public. And then several thousand volunteers completed the task in a matter of months, and each galaxy image was looked at 38 times as opposed to once. So this rendered really excellent quality data for the research team. And to make sure that the volunteers were classifying accurately, the research team binned a subset of data and then compared how well the volunteers did to the research team for that specific subset, and they found a 97% agreement between volunteers and experts. So the success of Galaxy Zoo led ultimately to the foundation of the Zooniverse platform. So since 2007, Zooniverse has evolved into the world's largest online platform for citizen science. The Zooniverse has hosted over 350 projects, not just in astronomy. We have a whole host of projects, and we have slightly over, I think we just reached the 2.2 million registered active volunteers worldwide mark. and many more volunteers who classify without formally registering. So I know this is an astronomy club, and Zooniverse is particularly famous for Galaxy Zoo and our other astronomy related projects. But I imagine that many of you may have scientific interests beyond astronomy. So I just want to take a minute or two to highlight the real diversity of projects that you can contribute to as Zooniverse volunteers. So many of our projects, regardless of their discipline, have this type of format where the research team has an image and they need the public's help classifying it. So tagging it, marking it, annotating, or binning it in some way. So this is a project called Snapshot Serengeti. I know that many of us are not traveling internationally right now. So if you want to feel like you're on safari in Africa, this is a good project to spend some time classifying on. So for this project, 25 people look at each image. The research team uploads a subset, like I said, for Galaxy Zoo of expert classified images to compare how well the volunteers classify animals when compared to the experts. And for this project, once again, there's roughly a 97 to 98% agreement between the experts and the volunteers. And oftentimes that 2 to 3% disparity, the experts can't even agree with each other on what they're seeing in the images. So we are really getting accurate and reliable results from our volunteers. Pretty much all projects on the platform use the same method of consensus or multiple people looking at each file. So in this example, we're looking at a marking task where volunteers are drawing circles around star forming regions within the Milky Way galaxy. So the task may vary a little bit between projects, but ultimately there's many volunteers looking at each data file and they're aggregated for consensus. So this is an example. What happens on the back end of all of this is that the research team is able to use these aggregation routines that are built out by our Zooniverse developers. And this is one where we see the raw classifications and then ultimately how the aggregation routine really comes up with a consensus result that's not quite as erratic. So what's really great about the Zooniverse platform is that we can take these tools and routines that we build, for example, like we just did for the Milky Way project, and apply them to other projects on the platform, regardless of discipline. So in this case, we're able to take this drawing aggregation routine developed for the Milky Way project and apply it to this project, which is called Etch-a-Cell, which is a cancer research project where volunteers are asked to stencil the nucleus of each of these cells so the research team can help differentiate between healthy and cancer cells for this particular project. So most recently, there's been a massive undertaking at Zooniverse to expand beyond the typical physical or biological science-based projects and expand into the humanities. So one of the ways Zooniverse has gotten into the humanities is by transcribing still images of old texts as part of an effort to convert these scanned digital images into searchable PDFs. So if you have ever had the experience where you were really interested in a topic in astronomy and you went to read a publication on it and it was published in the early 90s or the 80s or even in 2000, you may notice that your Control F function when you want to look for something in those PDFs doesn't work. And so that's what we're finding here with these ancient texts, and the Zooniverse volunteers are transcribing them so they become searchable in public databases. And one of the final efforts I want to highlight is the application of these tools to disaster relief, like this Hurricane Dorian project here. So as the storms around the world are getting more and more disastrous, we can use crowdsourcing as a way to help different communities in need. So as part of this effort, we were able to upload satellite images of communities that were affected by Hurricane Dorian. And this was, we took satellite images of these communities that we have from satellites in space before the hurricane, and then we got images after the hurricane struck, so volunteers could tag in the images where the roads were blocked, houses were destroyed, and this let rescue efforts know where to put temporary housing communities. And we partner specifically with an organization called Rescue Global, who uses these heat maps generated by the volunteers to determine how many resources need to be allocated to specific communities. So for this particular effort, 10,000 volunteers classified what would have taken rescue global staff over 2 years of images in just 1 week. So this makes a huge impact on the speed at which these humanitarian organizations are able to affect these communities and really help them. So through the Zooniverse platform and projects like all of the ones that I highlighted, we've demonstrated that consensus is really a powerful tool for scientific discovery and humanitarian efforts. And discoveries directly involving citizen scientists and the Zooniverse have led to over 200 peer-reviewed publications to date, and thousands more using the public data that ultimately the Zooniverse platform requires the team to release after 2 years. And then citizen scientists with particular expertise or maybe deeper interests can reach out to the research leads for the projects that they're classifying on and take a more active role in data analysis. And these citizen scientists have been added as co-authors to many, many of these scientific publications. So I want to highlight some of the more exciting and recent discoveries made by citizen scientists on the Zooniverse platform, featuring 2 of our most popular astronomy projects. So this one is called Exoplanet Explorers, where citizen scientists are vetting previously discovered planetary transits. And so when a planet passes in front of its host star, there is a temporary dip in the star's brightness. And this happens periodically as the planet continues to pass in front of the host star on whatever its orbital period is. And what the Exoplanet Explorers project was doing is that the machine algorithm that was behind identifying when transits occurred that was associated with the Kepler and K2 missions was missing some transits and finding some false positives. So the citizen scientists were going in and basically vetting these previously flagged transit light curves or identifying new ones. And just from this particular project year, this particular sector, which lasted about 6 to 12 months, the citizen scientists identified 28 new K2 planet candidates. So we find something similar with Planet Hunters Tess, which is a citizen science project where volunteers are not vetting previously identified transits, but instead are actually looking at transit light curves that are from the Tess mission, which is the Transiting Exoplanet Survey Satellite is what Tess stands for. And it was launched in 2018 to replace Kepler. It's a space-based telescope, and we are still getting lots of data from Tess, and the research team is crowdsourcing these transit light curves to the public so our citizen scientists can mark dips in the transit light curves and identify potential new planetary candidates. And through this, citizen scientists, I believe, with Tess have identified something like 25 or 30 candidates, and now 2 of those have gone on to be confirmed as actual planets. And the reason why citizen scientists have been so successful in these exoplanet projects is that they're particularly good at identifying planets on longer orbital periods where just one transit is recorded. So obviously, if a planet is further away, it's not going to pass in front of its star as frequently. So you're not going to see as many transits. And many of the automated pipelines built into missions like Tess require that the pipeline see 2 transits in order to mark it as a potential planet. So the human eye works really well in identifying solo transits, which oftentimes lend to the discovery of planets that are a little bit further away from their star. So these types of discoveries are amazingly beneficial to the field of astronomy, but what Zooniverse is particularly famous for are some of the discoveries that happen by accident. And this is why people-powered research is so valuable. So one of the greatest features on the Zooniverse platform are these talk boards that each project has, which allow volunteers to communicate directly with each other and the research team if they have a particular question or if they have found something strange or unique. Because humans have this innate ability to recognize patterns. So we can look at a data set and complete a tutorial or a training, and then look at something and say, this is really strange. I wasn't trained to classify this particular thing. So this brings me to one of the most well-known accidental discoveries from Zooniverse, which is called the Green P Galaxies. So volunteers classifying on the first iteration of Galaxy Zoo started a discussion thread famously called Give Peas a Chance. And this had a small collection of these green pea looking subjects from the Galaxy Zoo project. And they looked like the ones pictured here. And other volunteers eventually started adding and piling on more of these images to the thread. So it had over 100 comments. And this caused the research team to investigate, and they ultimately found that these green peas are small, compact galaxies, much, much smaller than our Milky Way. And they're some of the most actively star-forming galaxies in our local universe. And the citizen scientists who found them were credited on the paper. So another famous discovery was Hanny's Voorwerp, which came about when a citizen scientist and Dutch school teacher, Hanny van Arkel, started noticing these blue blobs near galaxies in the Galaxy Zoo project. And she posted her findings on the talk site, and the research team were able to ultimately discover a new class of objects called Quasar ionization echoes, which I cannot tell you any more about because I am not a cosmologist, but they're remnants allegedly of small galaxies that undergo some sort of radiation due to quasars. And they actually named these objects Hanny's Voorwerp, which means Hanny's object in Dutch. So a new class of object in astronomy was actually named after the citizen scientist who first identified it. And then you may have also heard of headline citizen scientists discover aliens. So this is the story of the WTF star, which is called the Flux Star, which was a Kepler object with a very strange transit light curve. So the leading idea now is that the system has a comet that is orbiting around the star, and the tail of the comet is actually disintegrating or breaking up as it passes in front of the star, and all the little particles are leaving this very strange transit light curve. But originally, it was more fun to allege that maybe it was aliens that were leaving us this strange signal. So Daryl LaCourse, who was a volunteer, was classifying in Planet Hunters when he came across this light curve. And he ultimately posted the object in talk and said, "This is really strange." And he shared his ideas. And I really enjoy that he ended this talk thread by saying, "This gave me an opportunity to play around in Microsoft Paint." So we definitely have volunteers that are much more hands-on in the projects and actually have some previous scientific background and go in and try to actually postulate what's causing some of these strange phenomenon. And those volunteers are typically added to the papers when the research team figures it out. So there are a few different groups of social science or crowdsourcing researchers in particular who are really interested in studying the Zooniverse as a system. So this study by a group of economists looked at the relationship between when the research team engages with their volunteers through the talk boards and the impact of the projects on the research field. So each axis is an aggregation across multiple metrics, like the number of posts on talk, the number of blog posts that the research teams give out, the number of articles and the number of citations to these articles. But the main thing to note from this figure is that there are no projects with high public engagement and low impact on their science. So the more the volunteers are really engaged with contributing to the science, the better the quality of the science really is. And some teams naturally have leaders who know how to do this well. And this is an area that we would like to expand at the Zooniverse in terms of training that we would provide to our research teams on how to engage and create a supportive culture between them and their volunteers that are classifying on the projects. I also want to talk a little bit about the amazing volunteers and the demographic breakdown of the people that are contributing to world-class science and making these discoveries. So they are everyday folks with an intrinsic interest in science, just like you or I. There are over 2 million of these people, to be exact, from over 230 countries around the globe, because our only barrier to access at the Zooniverse is that you must have an email address. Our demographics are relatively evenly split. except we find that in the astronomy projects, we have a lot more males, and in the ecology or biology space, we tend to see more females. So since many of you are in this astronomy club, I really encourage our female amateur astronomers and people interested in astronomy to get involved with our astronomy projects, so we don't see this skewed so much towards the male volunteers. This is also a breakdown of volunteers by age. So you see that many people are in their 30s. There's another big jump at 54 to 59. What we find is that the volunteers who are most involved, as in the ones who are doing maybe some extra legwork on the projects, tend to be people that have recently retired, but they're not necessarily scientists. They're just people with an interest in science. And we did a study on what motivates them to be citizen science volunteers. And ultimately, they like contributing to the scientific process. They want to contribute in a meaningful way to research. They don't necessarily want to leave research if they were previous academics, and they are not put off by the idea of being involved in research if they had never done so before. And they're fascinated by the projects they contribute to. So like I said, these people are overwhelmingly intrinsically interested in science, and that's why they want to continue pursuing it in their free time. So in terms of those 2 million volunteers, we really do have a handful of power users. So half of the classifications on the whole platform come from about 500 people that have made over 650 classifications, which corresponds to about 5 hours of effort, depending on the project. But of those classifications, 90% come from about 4,500 people. Most of the classifications on the platform come from from people who have classified for about 30 minutes. So most classifications come from people who peruse the Zooniverse website for about 30 minutes, but half of all classifications really do come from our power users who have spent more than 5 hours on the platform, which is really easy to do because it definitely gets addicting depending on the projects. So we know that human scientists are awesome, but it's important not to discount machines when it comes to looking at giant data sets, because that's definitely the direction that we're going. So humans are really good, like I said, at recognizing these patterns and making serendipitous discoveries and catching things machines miss or weren't trained to do. So what we're really doing at Zooniverse is starting to integrate the power of machines and combine that with the human eye to speed up our classification process on many of the projects. In astronomy in particular, one of the motivations for incorporating more machine learning is the LSST, or Ver Rubin Observatory in Chile. This is going to generate lots and lots of new astronomical data in the form of 20 terabytes a night or 60 petabytes in 10 years. So when I gave you the Galaxy Zoo example, that was a team that had 1 million galaxies, and we will be now serving 10 billion galaxies with LSST. So next year in 2022, we'll have a 25-fold increase in the amount of data that we're getting back compared to what we have today. We're practicing this right now, first with our Galaxy Zoo project, and this is the enhanced version of Galaxy Zoo, which you all can go and classify on if you're interested. But what's happening is that our machine learning program classifies images, which selects a set ultimately that it can classify really well, and then what would be most useful for improvement. And then the volunteers are classifying images simultaneously, feeding the machine new information. So all of the images are classified by about 3 volunteers, which is many fewer than the traditional Galaxy Zoo, which has about 38 to 40 people looking at each image. So an example of the efficacy and efficiency of this strategy is work that was done by a researcher named Melanie Beck, who created a workflow in Galaxy Zoo as part of an experiment. And she posted a subset of Galaxy Zoo data on the platform, so 200,000 galaxies. And she found that it took volunteers 300 days to classify all 200 galaxies. But on the 7th day after she released the data, she ran this machine learning program she wrote to bin the galaxies or perform the same task that the humans were asked to do. And immediately the machine learning algorithm was able to retire some of these easier galaxies with very identifiable features like very distinct spiral arms. And over the next 23 days, while humans were classifying on the project simultaneously and feeding the machine data, the machine learning algorithm retired all 200,000 galaxies. So it took 30 days in total, which was a factor of 10 faster when you have the human and the machine working together. So this is great for optimization, but we don't want to go to machine entirely and miss out on our serendipitous discoveries. So how can you get involved? I definitely want to end with this. One of the most fun, but one of the most complex ways to get involved is to build your own Zooniverse project. So this has been made possible through the use of the Zooniverse Project Builder. It's a totally free tool that anyone with a Zooniverse account can access. And this graph shows the amount of project launches between 2008 and 2018. And up until 2015, Zooniverse worked directly with research teams to build them custom projects. And this was a labor of love, but Zooniverse is a nonprofit organization with a very small development team. So it was launching roughly 2 projects a year with this custom consulting type relationship between the Zooniverse and the science team. And as the development team grew, the process became slightly more efficient. But in 2015, we received a grant to build what's called the Project Builder, which is kind of this automated plug and play web interface. And we went from launching 5 projects in 2015. Sorry, let me scroll back for a second. To it looks like 25 projects in 2016, 40 in 2017. And for the last 3 years, we're launching about 1 to 2 projects per week. So we've gone from 1 to 2 projects per year to 1 to 2 projects per week. And as many of you may be former scientists or current scientists, if you have any data you'd want to share or crowdsource, you can use our public project building tool to make your own Zooniverse project. And this is what the project builder interface really looks like. It's extremely user-friendly, similar to something like Wix or WordPress. And the goal of this tool is that anyone with an abundance of image or text or sound or different file-based data is able to build a project. And to be officially approved to launch on the Zooniverse website, like if you want the access to the over 2 million volunteers, the project needs to be approved internally by the Zooniverse team. But if you want to build a project for personal or classroom or professional use, you can use the project builder and launch the project privately. And that does not require any approval by the Zooniverse team. So if you're interested in Zooniverse for classroom use, you can get involved by checking out our Zooniverse Classrooms page at classroom.zooniverse.org. We have some great activities that are easy to incorporate in the more formal education environment rather than informally with volunteers just classifying in their spare time. And we'll be adding 2 additional labs at the end of the fall on the topics of exoplanet transits and climate change. And that incorporate the use of data from Planet Hunters, the project that I showed you, and another project called Floating Forests. And those are predominantly for introductory college students. So college age students that are non-science majors. And then you can always join in at zooniverse.org, and I've provided my contact information. And I would be remiss to, in 2021, not mention that we also have an app. So if you search Zooniverse in the Mac or Android app stores, you can classify on your cell phone by just swiping, depending on, you can bin galaxies with just like the click of your finger and swiping them in different directions. So I would encourage you, since you're all obviously intrinsically interested in astronomy, to give the Zooniverse a try and to get involved with citizen science, because you never know what you could discover. So that was my talk. Thanks for having me.
Are there any questions for Molly? Can you check? Okay. What?
What does talked about crowd surfing,
It's crowdsourcing.
crowdsourcing concept. Could she?
Molly, there was a question on the definition or what is crowdsourcing?
So crowdsourcing is soliciting the help of the public to essentially complete a task. So the science teams in this case, the research teams crowdsource an aspect of their data analysis to the public so that they don't have to do it themselves. So something that you're probably really familiar with, that's an example of crowdsourcing, is that if you want to go out to eat at a restaurant, you may look up the Yelp reviews of that restaurant to determine if it's worth going to eat there. And that's all an example of crowdsourced data, where ultimately, if the crowd has determined that it's a terrible restaurant where you're likely to get food poisoning, you probably won't go there to eat. But if there's 4.9 stars on Yelp, you're probably pretty confident that you're going to get a good meal. So crowdsourcing is really just soliciting the help of the public to inform any sort of decision-making process. And in this case, to do a component of a research team's data analysis process.
Thank you.
Thank you. Any other questions? Okay, well, we want to thank you very much for joining us in our first meeting in the new format, and apologize for any delays that caused, but thank you again.
Yeah, no problem. Thank you for having me. And if you have any questions, I can put my email in the chat.
Yes, we would, and we're also recording it, and I'll publish it to the group too.
That sounds great. Thank you again.
Thank you.